Hello everyone, let's solve GATE 2025 CS1 paper question number 20. So, you are given a recurrence relation T of n is equal to 2t n minus 1 plus n into 2 to the power n for n greater than 0 and T of 0 is equal to 1. And we need to solve this recurrence relation. In order to solve a recurrence relation, we need to know what is a recurrence relation. So a recurrence relation is a simple sequence which depends on another term and it forms a closed form expression and it computes T of n without recursion. So there are various ways to solve a recurrence relation. One is iteration or by an expansion. Another is like we expand the whole recurrence relation step by step. Another way to solve this is like using particle solution when there is a linear recurrence. What is a linear recurrence? When whose power is one. Like it is not like T of n, T of like it is not like constant coefficient. It should be linear recurrence with constant coefficient. Uh, there is another way of generating functions as well, and there is an like commonly used which is called the master theorem, where T of n, it is a generic formula for the master theorem where T of n is equal to A into T of n by B plus f of n. This is what master theorem formula is. Now we are given a recurrence relation in front of us and we need to solve it. Iteration seems like a best approach here because the recurrence relation is not homogeneous. Basically, there are non-zero additive terms is there, n into 2 to the power n. And it is not divide and conquer style. So master theorem won't apply. Master theorem only apply in the divide and conquer style. Like it in one of like master theorem applies in divide and conquer style, not only, but it does apply in master divide and conquer style algorithms. An additive term is non-trivial, so generating functions will be over. Like it is completely based on n, you can see. So there is no constant coefficient or whatever we call it. So let's try to expand it out. Like so, let me write that. ऐसा समझो यार कि ये जो रिकरेंस रिलेशन है, रिकरेंस रिलेशन को हम मास्टर थ्योरम से भी सॉल्व कर सकते हैं, बट यहाँ पे डिवाइड कॉन्कर टाइप का तो कुछ लग नहीं रहा. तो इसको एक्सपैंड करके देखते हैं. लेट्स सी व्हाट इट कम्स अप. सो टी ऑफ n is equal to 2t n minus 1 plus 2 to the power n into n. This is 1. Let me write that in front. Front में लिखता हूँ ज़्यादा सही रहेगा. So t of n is equal to 2t n minus 1 plus n into 2 to the power n. T of n minus 1 is equal to 2t n minus 2 plus n minus 1 2 to the power n minus 1. Now plugging it to T of n, so T of n becomes 2T of 2 into 2T n minus 2 plus n minus 1 2 to the power n minus 1 plus n into 2 to the power n. So it becomes 4T n minus 2 plus 2 n minus 1 2 to the power n minus 1 plus n into 2 to the power n. So this is 2 square. This is 2 to the power 1. This is 1, you can say. So it is 2 to the power 0. You can figure out a pattern here. It is like, so keep going. Let's keep going. So if I expand it a bit more, it will be for t of n minus 2. If I try to expand it, then t of n minus 2 will be 2t n minus 3 plus n minus 2 2 to the power n minus 2. If I expand it, then t of n will be 4 into that plus like if I try to solving it out, then if I replace it to t of n minus 2 here in one of the terms, then it will be 8t n minus 3 plus 4 n minus 2 2 to the power n minus 2 plus uh, 2 into n minus 1, 2 to the power n minus 1 plus n into 2 to the power n. If you see, there is a slight pattern here which you can see. So if I like try to generalize it, we just erase everything whatever I wrote in on the screen. So t to the power n is coming out to be 2 to the power k, t to the power n minus k plus summations from I is equal to 0 to k minus 1, 2 to the power I into n minus I into 2 to the power n minus I. This is what the generic terminologies are coming up. Now, 2 to the power I into 2 to the power n minus I. Both the bases are same, so the powers get added. So it becomes 2 to the power I plus n minus I, so 2 to the power n. So this further simplifies that we can multiply these. So it becomes, if I try to solve it more, then t of n is equal to 2 to the power k, t of n minus k plus summation of I is equal to 0 to k minus 1, 2 to the power I into n minus I into 2 to the power n minus I. This is what it is coming up. Now we can multiply these two terminologies. It comes out to be 2 to the power k, t to the power n minus k plus summation I is equal to 0 to k minus 1. Powers get added, so I plus n minus I will be I minus I 0. So 2 to the power n. 2 to the power n into n minus I. Now, you can observe here that this 2 to the power n does not have any effect like this, so we can get it out of the summation. So it comes out to be 2 to the power k, t to the power n, t of n minus k plus 2 to the power n summation of I is equal to 0 to k minus 1 n minus I. This is what the terms come up. Now, since you have got the t of n, uh, so let me write that. T of n comes out to be 2 to the power k t of n minus k plus 2, like I'm replacing I with random thing, okay, any value you can say, plus 2 to the power n summation of I is equal to 0 to k minus 1 n minus I. If I replace k with n, then uh, if I replace using k is equal to n, then t of n is equal to 2 to the power n t of 0 plus uh, 2 to the power n summation I 0 to k n minus 1 n minus I. If I t to the power 0 in the question was given to be 1, so it comes out to be 2 to the power n plus 2 to the power n summation I 0 to n minus 1 n minus I. So you can like uh, simplify, we can simplify that basically. So if I take this and put it somewhere else, so t to the power n is equal to 2 to the power n t of 0 plus 2 to the power n summation I 0 to n minus 1 for n minus I, where k is equal to n. Replacing it with 1, so we can replace this value with 1 as per the question. When you replace this value with 1, then uh, let's try to solve this. Like, let's try to simplify this a bit. So, summation of I 0 to n minus 1, uh, n minus I. So, if I put I is equal to 0 is equal to n plus n minus 1 plus n minus 2 plus n minus 3 dot 4, 3, 2, 1. It looks like 4 plus 3 plus 2 plus 1. It looks like a summation of n. So you guys know what summation of n looks like. Summation of n is n into n plus 1 by 2. We can replace this value with this. So t to the power n comes out to be 2 in 2 to the power n into 1 plus 2 to the power n into n plus 1 by 2. Taking common 2 to the power n is equal to 2 to the power n. We take common 1 plus n into n plus 1 by 2. This is what t to the t of n is coming up when I am writing again when k is equal to n. In that case, I'm only talking about because why? Because let's try for the biggest value of k in order to get the answer. So this is what it comes like. If I generalize it a bit more, if I try to generalize it a bit more, then what does it simplifies to? Because in the theta notation, we take the highest degree stuff, okay? And constants are ignored. So let's try to simplify it a bit. So 2 to the power n, 2 plus n square plus n by 2. So it comes out to be 2 to the power n plus 1 plus 2 to the power, let's divide it now. So n minus 1 into 2 to the power n minus 1 into 2 plus n square plus n. Okay, so let's solve that. So we are coming up with 2 to the power n minus 1, 2 to the power n. Let me 1 plus n square plus n by 2. So 2 to the power n minus 1 into 1 plus n 2. So if I have to take a base, 2 plus n square plus n. So that comes out to be 2 to the power n plus 2 to the power n minus 1 into n square plus 2 to the power n minus 1 into n. Okay. This is what it is coming around. Okay. So we know t of 0 is 1 and what else we need to know? So what are my options? What are the given options I have? So option A looks like uh, n square into 2 to the power n. Option B looks like n into 2 to the power n, log n square and 4 to the power n. So you can see you can eliminate option D, option C, and the only things now you need to worry is option B and A. Answer is any one of them. So let's try to see the term which was coming out to be 2 to the power n, uh, 1 plus n into n plus 1 by 2. So 2 to the power n minus 1, 2 plus n square plus n, 2 to the power n plus 2 to the power n minus 1 n square plus 2 to the power n minus 1 into n. So now, what term to take? What terminology actually have to take? So this is just a this is actually a division of two. I can if I try to write this, this is what it actually looks like. Okay, so it actually looks like 2 to the power n plus 2 to the power n upon 2 n square plus 2 to the power n upon 2n. This is what it looks like. And we have already simplified that is the bigger term here. So now, if you guys remember in theta notations, we ignore the constants. So if you guys see, this is 1 by 2. 1 by 2 is a constant. We can definitely ignore that. So it comes out to be 2 to the power n plus 2 to the power n square plus 2 to the power n into n. This is what it actually comes out. Now, if you observe which one of the is the bigger term. So this is exponential and this is quadratic, both multiplied. This is the biggest term. So we take the biggest possible and we technically ignore other ones. So if I take this out, so other terms. So option A and option B both are right now part of this. So which one is bigger of them? Obviously the n square one, n square into 2 to the power n is the bigger one. So option A is the right answer. So order of in theta notation, n square into 2 to the power n is the correct answer, as we can see from the derivation. That's it for this particular video. Take care. Bye bye. See you guys in the next video.